How do exploration and exploitation work in RL? Imagine you're trying to find the best way to win a game or solve a puzzle. You could keep doing what you already know works or try new things to see if they work better. That's the core idea behind exploration and exploitation in reinforcement learning. In reinforcement learning, an agent learns to make decisions by interacting with an environment. It gets rewards for good actions and learns from the results. To improve, the agent needs to balance trying new actions and sticking with what it already knows. This is where exploration and exploitation come into play. Exploration means the agent tries different actions or visits new states to gather fresh information. For example, if a robot is navigating a maze, it might take different paths to see if there's a shorter route. Even if some paths don't give immediate rewards, exploring helps the agent discover better options for the future. Exploitation, on the other hand, is when the agent uses what it already knows to get the most rewards. It chooses actions that have previously led to good results. Think of the robot repeatedly taking the path that has worked well before because it's the safest way to reach the goal quickly. The tricky part is deciding when to explore and when to exploit. If the agent explores too much, it wastes time on actions that might not pay off. If it exploits too much, it might miss out on discovering better strategies. This is called the exploration-exploitation trade-off. There are different ways to manage this balance. One common method is called epsilon greedy. The agent mostly exploits its current knowledge but occasionally explores randomly. For example, it might explore 10% of the time and exploit 90%. More advanced strategies adjust this ratio based on how confident the agent is about its knowledge. In real-world AI tools like ChatGPT or image generators like DALL-E and Midjourney, exploration can be trying out new prompts or creative ideas. Exploitation involves refining prompts based on what has worked well before to produce better results faster. Similarly, productivity plugins learn user habits and decide whether to suggest new features or stick with familiar workflows. Balancing exploration and exploitation is essential because too much of one can limit learning or waste resources. Properly managing this trade-off helps reinforcement learning agents become more effective and adaptable over time. It allows them to learn new strategies while still making the most of what they already know.